when you look at questions like this that are so complex and could have so many down the line implications for the decisions that people are making today, it really is eye opening to understand how little we really know about like the full socioeconomic impact of just earth observation data and services, let alone like how deep learning can contribute to our socioeconomic well-being. I mean, the best estimates that people come out with are like 100 to 150 billion over the next 10 years or so, but that's not even really understanding what the full capabilities of deep learning will be by then.
Welcome to another episode of the Mapscaping podcast. My name is Daniel and this is a podcast for the geospatial community. My guest on the show today is a rare mix. She is a geospatial scientist and a product marketing specialist at Up42. And today on the podcast, we're going to be talking with Elizabeth Duffy about urban estimation and the role of deep learning, machine learning, and Earth observation. Just before we get started today, I'd really like to ask you for your support. So I'm not about to ask you to send money or to buy more stuff that you don't need. All you have to do to support the podcast is to share it with someone. So at the start of every episode, I say that this podcast is a podcast for the geospatial community. And what I'm saying there is that this is not for everyone. This is for a very specific someone. This is for people like us. So if you know some people like us that might enjoy a podcast like this, please share it with them. I would really appreciate your help with this. Hey Elizabeth, welcome to the podcast. I'm pleased that this is going to happen. It's been a while coming, so this is great. So you are a project scientist for something called the Decider Project. You also work for Up42. Would you mind just introducing yourself to the audience, please, before we jump into some of the amazing work that you're doing?
Sure, yeah. Thank you, Daniel, for having me. So I am, just as you said, project scientist with Decider, product marketing specialist at Up42, have over 7 years of combined education and professional experience developing, implementing, and promoting geospatial tech for both private and for public applications. And I've gotten my hands dirty in a little bit of everything geospatial related, but more recently, I've focused on automating insight extraction with machine learning and interferometrics. And with the latter of that, I've actually published in a peer reviewed journal recently. So, yeah, that's pretty much it in a nutshell.
That must be a big nutshell because there's a lot of stuff in there. Could you just tell me what the last thing you said was? You said you had automation and something I didn't quite get it. Would you mind just walking me through that?
Oh, automating insight extraction with machine learning and also interferometrics.
What is interferometrics?
Interferometrics, or INSAR, as some people call it, is essentially taking stacks of radar data and looking at it over a certain time scale and seeing how these slight changes in elevation are occurring. So it's used for subsidence analysis. You could also use it for understanding when there's some sort of risk, maybe karstification or when there's going to be a landslide. So you're basically just looking at where there are small changes in movement of the Earth's surface.
That sounds really interesting. And does this have something to do with the Decider project?
Yeah, absolutely. Absolutely. This publication recently was actually tied to this Decider project in Ho Chi Minh City. And we used stacks of 2 years worth of Sentinel-1 radar data.
So we've said the name a few times now. Would you mind telling me what it is that Decider does or is seeking to do?
The Decider project, it's really like a consortium of 8 different universities across Germany, as well as several different partners based in Vietnam in Ho Chi Minh City. And what we're trying to do is gather all the most current data and analytics to create a decision support tool for flood risk in Ho Chi Minh City, which is a significant problem there for all sorts of reasons, from sea level rise to, as I was saying, the subsidence that we've analyzed there, as well as, increasing precipitation and things like that, and groundwater extraction due to urbanization.
And is it enough to, I mean, can you make significant decisions or calculations about what might happen based on looking at these small changes in the Earth's surface over time? Or are you adding something else to the mix in order to sort of help make decisions about where things should be built, infrastructure that needs to be moved, or perhaps added to certain areas? What kinds of data layers are you using apart from SAR data?
For the other people in the research group, they're doing a lot of different things, not just looking at geospatial data. They're looking at a lot more of like these like financial metrics and things like that, and also hydrologic data, as I was saying. But my component, my contribution to the Decider project is I'm actually looking at these urban structure types. I'm trying to determine first and foremost where buildings are and where they are not, because this is a major issue when it comes to rapidly developing cities in that they lack the cadastre data that a lot of places like the United States or quite a bit of Europe have readily available. Their governments just lack this data. And it's really important to discern not only where these buildings are, which is one of my main contributions, as I was saying, but also what types of buildings they are and where. The where component is the most important because if we see that there's, maybe some rapid urbanization happening in areas where we also assess their subsidence, as these cities are rapidly expanding, as Ho Chi Minh City is, then, that's a problem that we need to flag and assess. Like, how does this trend contribute to like future risk? As well as there's a lot of these illegal settlements as well along the rivers, which governments turn a blind eye to because maybe these are more destitute situations. So we need to assess where these buildings are as well, because a lot of times they're located along rivers and things like that, where it's very prone to flooding.
You'll have to forgive my ignorance here, but is this a hard problem to solve? And if so, why? Because it seems to me we live in this world where we can determine so much based on satellite data and identifying whether a house is there or not. It feels like something that we should already be able to do. Would you mind sort of walking us through that side of things? Like, well, why is this a hard problem?
This is a really difficult problem because Ho Chi Minh City itself is a city of 9 million people and growing. And to start that data from scratch is extremely tedious and difficult to do. So, the reason why it's important, not only to obviously have something that can scale, like with geospatial data, but to have, the right answers, you need to have a clear and current understanding of the situation at hand so that you can discern the right solutions. So, this is coming down to having the right data, knowing where these buildings actually are. And to do that at scale without something like geospatial data, so to do it with something like Insitu or to have somebody, manually and go in and draw all of these buildings for again, the 9 million people that live in Ho Chi Minh City. It's such an immense task. And so that's where it's also important for us to leverage some tools that scale so the government can feel that they can start implementing new infrastructure immediately and sort of continue to monitor and adapt to changes. So now that you have the right data and you can actually apply the right analytics to get the right solution.
So you mentioned scale quite a few times there, and I can completely understand that. I mean, going around and manually measuring or geolocating buildings, identifying buildings, just doesn't seem like a feasible solution. So I understand that side of it. When we talk about identifying buildings or understanding whether a geographic area is urbanized or not, are we also talking about what kind of urbanization is happening there? What kind of buildings are being built? Is that important?
Yeah, absolutely. So, when we're looking at the types of buildings being built, you need to understand you can use that as a metric for essentially how many people are living in that building. You can also, as I was saying with other partners that we have, that they've collected some of this survey data, these financial metrics that you can actually assess what is the sort of quality of life or even like what is the actual expense if this building gets damaged, not only in the number of people that one might expect to be affected or impacted by, let's say, like a flood event, just keeping it to Ho Chi Minh City, but also how much might a person be willing to spend to maybe do their own protective measures, putting sandbags in front of their buildings or their shops, or maybe installing some systems like rain barrels or things like that, some prevention measures. It's really just a metric of like how much people would actually be able to invest in protecting their building, how much damage they would have, and how many people would be at risk.
So this makes perfect sense. If we can identify these buildings and identify what kinds of buildings we have, geographically locate them, then we can start attaching these other attributes there and making decisions based on that in terms of the economic feasibility or potential for protecting themselves, I think was one of the use cases that you talked about there. So I guess my next question is, have you managed to do it? Have you managed to identify not just buildings, but the types of buildings at scale?
Yeah, absolutely. There's kind of two different methods of attacking this problem that we outlined. So first, there was the machine learning approach where there were all of these different derivatives that you have to produce. So, there were things like PCA analysis, we had to do a topographic position index. We were looking at things like canny edge detection of where these buildings could be delineated. You have maybe something like an NDVI, that's fairly standard. And then like water masking, all of these different components that had to go in, that we had to derive before even really getting started with that machine learning process of even just identifying where there was a building and where there wasn't a building. So this is excluding the actual categorization that we have.
Are you creating these derivatives as a way of sort of masking out areas of non-interest, or could you just walk us through, like, why do we need to create these derivatives to run a machine learning process? What was the goal of all this?
So the goal is to identify where the buildings are and where they aren't. So it's essentially feeding into your machine learning algorithm these different types of data sets that can help the computer to make the most educated guess over where a building is or where it isn't. You can use some things like maybe just NDVI, for example, that was going to tell you where the vegetation is and where it isn't, but you might also in that end up including a lot of things that you don't want to include or also excluding things that you don't want to exclude. So maybe like a building with a green roof or something a building that has maybe more of like a biomass or a tar type roof or even, terracotta clay, which is essentially the same material as soil on the ground. So you have to have all of these different components fed into these machine learning algorithms so that you're getting the best quality of results of where just literally just where the buildings are or where they are not.
So you're making this sound really complicated, and normally when people show up and say that they're doing machine learning, it sounds like that was the answer, but it doesn't feel like it in this case. Was there something else that you used, or did you have to go through all of these steps to be able to solve this problem?
What we ended up doing was also testing out what are our opportunities to leverage deep learning. And, this is where I think the most potential comes into play, especially when we're just looking at, we just have these two data sets that we're working with. We just have this high resolution imagery and a normalized DSM, which we were deriving all of these components from with the machine learning. However, with the deep learning methods, essentially what you're doing is you just take the optical imagery and you can just train a database just doing this the same thing. Yes, it does take some time to build up a repository, but we even have this urban estimation algorithm. There's one that's been produced by one of the partners of Up 42, which performs extremely well. And you could go to Up 42, analyze 75 square kilometers. I just tested it today. And just with the data that you want to use, it takes 4 hours to finish running. So imagine if you took all of this time to build up just to get to the framework where you could start estimating where buildings are or are not for machine learning. All of those man hours, that's, somewhere like 3 months time of somebody not only getting all of the derivatives prepared and properly calibrated or executed, and then also building up, some machine learning algorithm, which I mean, we're very lucky today that we have all of the different software capabilities that we have now, eCognition, all of ArcGIS Pro capabilities, et cetera. But there's still a lot of time and manual effort looking up just to find out the right things to do. Whereas, with deep learning, for something like this, like I was saying, this urban estimation, it's literally just they have built this repository. You just go ahead, feed in the data into the algorithm, and then 4 hours later, you have a reasonable answer to start off your analysis.
I just want to understand. So you're saying you're building up a repository. What does that look like? Is it some sort of heads up digitizing thing where we have our data layers and we go in? We talked about using high resolution aerial imagery and manually tracing around to these buildings where humans do it first and they build up a repository, a training set, and then we run the algorithm.
That's generally the way that, deep learning is done. You set up a framework, you're using something like TensorFlow, PyTorch. There's generally somebody who is, yeah, manually going in, labeling this data. And the great thing about it is that, so after you get to a certain level of performance of training this data to be fed into the algorithm, and you do maybe some analysis, that you can just go back and you can pick up where you left off and continue training and refining this data. And so it's sort of it creates a positive feedback loop where, the more that you train, the better it's going to get. And you can also have it be catered very region specific. So if you know that there's within Southeast Asia, for example, a lot of the buildings can be very, very similarly structured. This is a part of what makes Vazindhara's algorithm work so well, is that they've trained it in sort of one of the most difficult locations to do this sort of building detection, which is in Southeast Asia. You have all these buildings that are highly clustered, unlike places like in the US or in Australia, where you have all of these buildings that are, sort of nice and neat in these sort of grids, spaced, kind of equally spaced between each other.
Does this mean if I solve this problem for Ho Chi Minh City in this particular instance, can I just take that same recipe and copy paste it and use it in other geographic locations, let's say within Vietnam or within that sort of general geographic area?
So with the deep learning methods, that's the idea. That's the entire idea behind it, right? Especially when it comes to something like urban estimation, where you're not actually necessarily predicting the type of buildings or like the number of people that are living there, where you're just doing the actual, is this a building or is this not a building? It definitely can be replicated for any similar urban environment, but especially ones that are similar in geographies and the infrastructure types that you would see. So then when it comes to the actual identifying some of these metrics that we are talking about, like maybe, what type of building this is, like, let's say predicting whether or not this is some housing unit, which maybe has 4 to 7 people living in it or something like that. That would be much, much more dependent on probably some of like the cultural factors there.
So urban estimation, how we talked before about these other data points that you were collecting in terms of economic income, that kind of thing. I guess there's some kind of in situ measurements that are being made in terms of that. Are they all being tied back to these data sets? So once we identify the houses, identify the buildings, and perhaps even what type of buildings they are, we tie these other data points back to them. And what kind of ground truthing do we do to sort of validate the model, to validate our results?
Yeah, that's a very good question. So there are certain things, so especially when I'm talking about the actual geospatial data, the actual sort of physical validations that we need to do. So that could look like I'm taking this normalized DSM, so which is just essentially subtracting a DSM from a DTM to get the heights of different buildings. And using something like maybe LiDAR data that is generated from that's of very high resolution, I know that I can have a certain level of accuracy of that data, but I still want to go in on site, actually do, these field measurements and actually measure some rooftop information, some the actual height information on site so that I ensure that the answers that I'm getting from my normalized DSM are matching up with what we can see in reality. So that's just like on a physical basis, that validation. But then we have the validation of these financial metrics that we were talking about. So this has to be done with, as I was saying, these survey campaigns. So what we do is that we take these very, very broad surveys. We get these large data sets of surveys asking people actually quite a bit of very personal information, like ranging from how much does your roof cost, or how much, when did you recently have any repairs to your roof and how much did that cost, something like that. if we are able to ask what their income is, we get that sort of information. Are they running a business from their home? How many people do they have living there, et cetera, et cetera, et cetera. And then we take that survey data and we split that up into what is actually going to be used for us to sort of draw our conclusions of what we think these buildings are actually matching up to versus what we're actually going to use for the validation tests. So it's really important to make sure that you're splitting up that data properly, that you're not using the same information that you're making your hypothesis on for what you're actually validating with. So I think that that's just a general issue of scientific rigor more than anything else, of ensuring that you're splitting up those data sets properly.
Just so I understand this, when we talk about splitting up the data sets, we've got these in situ measurements, field measurements, surveys that we've got. So, are you in fact going out to objects that you've located and saying, hey, well, this is an object of a certain size, a certain shape, a certain roof type, something like that, making these measurements there, doing these surveys with the people or whoever it is that is in the building, and then coming back and saying, okay, well, we can make some assumptions now that buildings that look like this should be given these attributes. Is that what's happening?
Yeah, exactly. Not necessarily in that order, but we kind of derived the actual buildings first just to get an idea of the overall like distribution of different buildings, and then we did the survey, and then we're doing this actual like building type analysis. But yeah, in a sense, that's exactly what we're doing.
What do you imagine the relationship between in situ measurements and remote sensing will look like in the future? Do you think will we always need to do these in situ measurements, or will we be able to remote sense everything?
Yeah, that's a really good question because in the past, we've relied so heavily on these in situ measurements and manual labor, which definitely should still be leveraged, but more as just calibration and validation. It shouldn't be where our answers lie. It should just be for us to correct where we've already determined some answers, and sort of, as was saying, calibrate and validate are the insights that we're getting. Because in situ measurements and this manual labor, it's just not scalable. And so when we're looking at the cost of these things versus the decreasing costs and increasing availability of Earth observation data and even access to just cloud computing, it just is making less and less sense to try and use these on site measurements for scaling.
How far along is the project?
Our contribution to it, that will end coming this October, but the actual entirety of the Decider project itself will extend for another 2 years as they take all of this data that we have extracted and interpreted, and they actually import it into this, again, this decision support tool. So, a web mapping platform that anybody can have access to. So, not only governmental stakeholders or small businesses and corporations that have an interest, but actually just everyday people as well. So they can hopefully have the data that they need to make proper decisions about flood risk in their community.
Yeah, I guess when you talk about people making decisions, like what kind of decisions do you think that they're going to make? I realize that it's not finished yet. You haven't seen the finished product or haven't seen how it's going to be implemented in terms of this web mapping tool that you talked about. But what kind of decisions are they hoping that people will make from this data? Just simply not to live in certain places, or is there something more going on?
Well, hopefully that actually will be a contribution that this will have, that people make better decisions on real estate decisions, but it could also have, when we're talking about the government, different things in regards to zoning could be very pertinent, or for people to understand maybe if they're looking at where their companies are, so not just like personal real estate, but also where their small businesses are. What decisions might they need to make now, understanding future risk of what investments they can do for their infrastructure in order to make it more resilient? So these are some of the things that I was sort of touching on, like maybe you want to build these rainwater catchment systems, or potentially you want to have some district level community rain garden or sump, where essentially you can have, when there's an excess of rainfall or something like that, where this water can have a place to flow that isn't in your small business. And it's really incredible to see when you look at questions like this that are so complex and could have so many down the line implications for the decisions that people are making today. It really is eye opening to understand how little we really know about like the full socioeconomic impact of just earth observation data and services, let alone like how deep learning can contribute to our socioeconomic well-being. I mean, the best estimates that people come out with are like 100 to 150 billion over the next 10 years or so. But that's not even really understanding what the full capabilities of deep learning will be by then, how this satellite data will advance. So, I think there's so much potential out there. I'm really excited that we're a part of helping people to answer these questions. And I really hope that people take on Earth observation data more and more.
Oftentimes, when we talk about Earth observation and this kind of monitoring, we talk about some really, really big numbers. I mean, it's a lot of data. Oftentimes, it's models that need to be run continuously because we're interested in change over time. And then the implications of the things that we discover when we're doing an analysis, they take time to implement. They take time to move populations. It takes time to shift a culture. When you're working on these kinds of problems, is it exciting or is it overwhelming?
It can definitely be a bit of both, especially when there was a recent digital elevation model, global digital elevation model that actually tripled the estimate of global vulnerability to sea level rise and coastal flooding. And when I think of something like that, I mean, we already knew that the problem of sea level rise was going to be a big one. And now we understand that actually a lot of these buildings were actually creating a level of backscatter that was influencing what we thought the elevation was. So it actually was making these cities look like they were higher than they were. And now we've actually, again, through machine learning, have determined that they're much lower. And so I do look at things like that and the amount that we're going to have to spend in the future on these infrastructure changes. And it definitely can be a bit daunting. But where it becomes really exciting is, again, this understanding that deep learning, the more time that we invest in it, the better and better it's going to get. And not only that, but when we make the right decisions of where we're going to invest our infrastructure, it can save so much money in the long run. I think that governments sort of too quickly can sometimes come to the conclusion that they need to look at things like dikes and levees and use these sort of like in situ measurements, which just don't scale to justify these projects for things like flood risk. And you look at something like New Orleans and the aftermath after Hurricane Katrina, and the levees did actually quite a bit more damage than they did good after they broke. If we use Earth observation data to help us make the right decisions for infrastructure, and then we invest in deep learning, understanding that the more that we invest, the better and better it's going to get. And so the better and better our answers are going to be. Then it becomes a much more exciting situation, even though it is a bit daunting. I really see it as the David and Goliath situation where this is a Goliath of a problem, but Earth observation data, and especially when paired with deep learning, is the slingshot that will facilitate David's success.
That is an Instagram quote right there. Thank you very much for that. So you're working with governments, you're working with these organizations. Do you ever have the feeling that there's an incentive not to understand the data in case that, this is, if we understand it, if we truly understand it, we might also truly understand the scale of the change that needs to happen. Is there ever a time where you feel like, oh, I don't know if these people actually want the answer?
That can be the case sometimes, especially if there are, private interests. Sometimes if, let's say, for the case of if there was too much groundwater extraction and that was causing a lot of subsidence, for example, which can definitely be the case. It was in Ho Chi Minh City. You've even seen it in Beijing. It was an enormous problem. You even see it in California quite extensively. And there can be some vested interest into not really discovering how rapidly that subsidence is occurring. But at the same time, people can see what's happening in their neighborhoods. Sometimes it can be creep, but things catch up to you. And I think that most governments do want to find the right answers. It's just that not everybody is recognizing that these answers are readily achievable and scalable in the information and technology age that we live in right now. A lot of these technologies are very new. Even, the Pleiades data set wasn't around, a full decade ago. So it's just a bit of catching up, a bit of raising awareness of what is actually achievable. And I think that podcasts like yours are definitely doing that.
Thank you very much. So I don't want to belabor the point too much here, but I'm curious, like, what is your role as a scientist? Is it just to deliver the data, to do the work, to do the research, do the analysis, say, here, there you go. Is that it? Like, write the paper, or do you see it as being something more?
That's a really good question. I think that my main goal is to deliver and explain the data and how our answers were achieved so that people have an understanding of how we're actually coming to these conclusions, not only so that people can try and replicate these things and improve them, but also so that we just demystify how the answers are actually drawn and so that people can understand where there might be biases or flaws, such as maybe for the case of Decider, where we've actually conducted surveys and where we have not, because there can be, maybe some potential biases that we focused on areas that we found to be more prone to flooding rather than those that weren't, just because we knew that that was of the highest priority for our research purposes. So I think there is definitely the component of it of also conveying what that information is actually doing. When it comes to actually advocating for what the change should be, I think that that is where it's important to take our best knowledge from our wheelhouse and just sort of invite these private sector people and also government bodies who are more attuned to like what are the actual budgets that people have, what is actually financially reasonable for them to make those decisions on what's best for their communities.
I'm really pleased that you talked about demystifying things there because this is a great lead on to my next question. And it is around demystifying this machine learning and deep learning, for example. Because when I talk to someone like you, you're really positive about it, you're optimistic. That great quote there about David and Goliath and machine learning, deep learning being the slingshot, absolutely love it. Do you have the feeling sometimes that people think that this is a catch all? We'll just do some machine learning. We'll deep learning will solve that.
I actually think, at least in the scientific community, at least with deep learning, especially, it can be the opposite because a lot of people become a bit scared that they know that there's training data going into the deep learning, but they don't know what the computer's actually doing, what decisions it's actually making within the system. And I think from a scientific basis, there's a lot of people that are actually, they find aversion in that they can't actually explain maybe where error is occurring or why certain things are being detected better than other things, other than the fact that maybe the training data is biased itself. I actually think in the scientific community, people can be a bit afraid of deep learning and not see the potential that it can have. When it comes to the actual demystification of actually applying these data sets within, maybe like the private sector, I think that the private sector is adopting these things a lot more readily. We see that at Up 42. What the larger issue is that a lot of people that are very interested in exploring these things, developers, for example, they just don't have the resources to set up these frameworks. And it takes a lot of power to run deep learning algorithms. Hopefully, with more and more platforms like Up42 popping up, that we see this greater recognition of what the potential is for deep learning and that becomes unlocked.
Yeah, I guess I'm sort of stuck on that idea that the problem is that technical problem where they don't have the platform, where they don't have perhaps the technical expertise to run it. I mean, I completely understand that argument. I would also make the argument that they perhaps don't understand the use case or a use case that would fit in their circumstance. So, maybe they're not measuring the earth in some way, shape, or form. Maybe they're trying to do something completely different. And I guess for some people anyway, it might be a real sort of mental leap to say, hey, we can measure the shape of the earth in Ho Chi Minh City, and therefore we can calculate all these other things and help perhaps mitigate some flood risk. Like moving from that to we're going to do something with Earth observation data and it's going to have a financial impact, a positive financial impact on our business. That might be quite a sort of mental leap for a lot of people. That might be the thing that's holding people back.
I do think for situations like very complex situation that we're looking at for Ho Chi Minh City, that definitely can be the case. But there are some opportunities like we see with, maybe shifting gears here towards some other use cases. Vegetation management, for example, can be an enormous problem that really readily goes unseen. And a lot of times we've used utility companies have just done again, these in situ measurements, actually having these people even flying helicopters over kilometers upon kilometers of these power lines to assess where there's maybe like some vegetation growing nearby. And this is actually a really major issue because even just we look back at 2017, there were 12 wildfires in California, just California alone, that were caused directly by utility the electric power grid, where this very dry vegetation was interfering with electricity and it caused sparks, and this caused these massive wildfires. And all people need to do with something like deep learning or machine learning is assess with optical imagery how close this vegetation is to a power line and maybe with a normalized DSM see like what the height of the tree is, assessing how close it is to a utility line, and you have your answer. So, a fairly straightforward approach. I think that there's a lot of opportunities, just like this example, where it's directly these developers could be, and we do see them working with these utility companies to help not only protect the environment, but also protect their assets and protect their reputation. And it's really just a one and done type situation. It doesn't have to be so complex where you're taking these field surveys and you're assessing, you're going to each individual household and seeing how much money they're making, et cetera, et cetera. And again, even when we're talking about like these situations in Ho Chi Minh City, hopefully eventually we'll also get to a point where the census information is more readily available, and so that can help us in setting up these monitoring situations moving forward. It's just facilitates us setting a baseline, a base level from which further analysis can be drawn.
Can we just stay with that idea of the wildfires just for a second here? Because I think that maybe, like me, you're suffering from the curse of knowledge. Like you understand how you can do this thing, right? You're looking at the situation going, oh, you can just do that and just do that and just do this. And we have the technology and we have the algorithms and, we can do this. We can make it better. I don't want to trivialize wildfires in any way, shape, or form, but I work for a utilities company and I see people on a daily basis asking for a PDF because that is their map. And I'm constantly, you could just look at the map that we're updating on a regular basis for you on this thing called the internet. And you could just do that and it would be so much better and it would be bright and shiny and it would solve your problems and you can interactive zoom in and out at different scales. It would be amazing. It'll even show you where you are on the map. And, that's my curse of knowledge because I find myself constantly saying, you could just do that. I think the people that we're trying to move, the people that we're trying to change, they aren't quite at the same stage of their journey just yet. And I think it takes a lot of sort of empathy to move people from one place to another. And I think really we've got to be careful when we talk about, oh, you could just.
That's really fair. That's really fair, Daniel. I appreciate you bringing that up because the positioning of 42, the people that we're working with, they do have more of this developer mindset where I'm not going to run into anybody that isn't extremely familiar with the internet and web mapping, things of that nature. But you're definitely right with the people that are actually going to be benefiting the most from this technology. And these are the people like the folks working at the utility company or with the vegetation example or with the example with Ho Chi Minh City, it's the people actually running the shops at a very low lying elevation, these are the people that are actually going to be the most affected and impacted. So that's where I think it does become important for people to educate themselves. And I think that we've actually seen that quite a bit with just the potential that people have to understand and readily read maps. I mean, with Corona, I don't know about you, but I was checking John Hopkins' COVID map almost daily at the beginning of the pandemic. And I think that I'm not the only geospatial nerd out there that was looking at these maps, that there were a lot of people that understood that this was valuable information that was helping them understand their surroundings. I actually think that maybe that this situation could open a lot of doors for people to what, as unfortunate as the COVID situation is, but what the potential of geospatial mapping for risk analysis and risk mitigation can be.
So you've given us some really interesting use cases. You've talked a little bit about your work with the Decider project. Is there anywhere we can go where we can follow up with some of these things, or if perhaps if we could reach out to you personally and connect?
Yeah, absolutely. I would encourage anybody to reach out to me personally, put my email information in the description if they want to reach out to learn more. We also just had our infrastructure webinar on remote sensing. The title was a replacement for ground based monitoring of critical infrastructure, sort of posed as a question, which has a lot of the insights actually that we've sort of touched on today. There was some really interesting question answered there that I would encourage people to go and watch that recording of the webinar. And then of course people can go to up42.com and sign up for our actual platform, and with that they'll get 10,000 credits to go ahead and start testing.
Awesome. I'll make sure to include those links in the show notes. Elizabeth, thank you very much for your time. Really enjoyed the conversation, and I appreciate you taking the time to talk with me.
Thank you so much, Daniel. Really loved chatting with you, and it was a pleasure being here.
So I really hope that you enjoyed that episode with Elizabeth Duffy, geospatial scientist and product marketing specialist at Up42. I will be sure to include links to the webinar that she mentioned in the show notes, so you can watch that if that's something that you might be interested in, and also a link to Up42 itself, so a link to the platform where you can go along and take advantage of that offer of 10,000 free credits to try things out, to play around and see if it's something that you might be interested in using. And that's it for another episode of the Mapscaping podcast. Thank you so much for tuning in again this week. It's much appreciated. As I mentioned at the start of the episode, I would really appreciate your support. And all you have to do to support the podcast is just to share it with someone. Find someone you think might be interested in it, might benefit from listening to this podcast, and tell them about it. I would really appreciate your help with this. As always, you're more than welcome to reach out to me on social media. You can find me at Mapscaping on Twitter, and I'm relatively active on LinkedIn, so you can find me there. You'll find a link to my LinkedIn profile in the show notes. And of course, you are more than welcome to contact me on email, just info@mapscaping.com. I would really love to hear from you. Okay, that's it from me. We'll talk again next week. Bye.